Here is the first main topic we are going to discuss. Mm, Conservation laws in elementary particle reaction. Okay? In previous class, we are just discussing about the classification of elementary particles, how this classification happened based on the Bose-Einstein distribution of perimeter distribution of their in half integral pair. Some pions, mesons, hadrons are there. So this is the main classification. First topic is here we are going to discuss the first topic. So this is our main course. Conservation laws in elementary particle reaction. So if you know the classification, then you can easily find these conservation laws. Okay. First conservation law going to give that one conservation of lepton. This is denoted by L. Next, conservation of variant number. This is denoted by B. Next, conservation of isospin. Conservation of isospin, third component of isospin. Okay. So for clarity, this is conservation of third component of isospin. Okay. This is denoted by I3 or IZ. Next, strangeness number. Conservation of strangeness number. Okay, first I'm going to discuss the conservation of lepton. What are the leptons? So I'm going to define this lepton number like this. This definition I took from the DC Thile book. Lepton number. You really want to study each and every elementary particle, how they are discovered, whether really exist or not. You need to study the Griffith textbooks. So this lepton number L, right? The number of leptons minus the number of antileptons is called number of leptons, lightweight particles, right? electrons, muons, tau cesium of anti lepton are conserved. Okay. So the leptons, uh, less one leptons are there. The leptons, normal leptons classified, and their antiparticles are also there. The antiparticle number is -1. General lepton number is divided by +1. Okay? Their antiparticle is -1 leptons. Remaining all particles, the other variants measure the lepton number because those are not in the category of leptons, right? Are the others. Okay? Others, which means variants, measure. So we need to remember lepton classification. Okay? So leptons classified into separately these categories. This is electron, right? See here the leptons classification. These are the leptons, right? One, two, three leptons are there. So they not here. So there is more clarity here. Uh, Main classification here, the leptons classification. So you can avoid this thing problem. You just remember the electron muon, how electrons. Okay? This is defined by the LE, which means this E indicate the electron category. Okay. Therefore, here I am going to classify this thing like this. Electron, I am going to design E minus. The electron antiparticles is E plus. Please remember this is electron. Charge is minus, right? This antiparticle is plus. This I am going to define like this. This I am going to define like this. Not giving any more this one. So this is the best way to remember all our net and gate exam. So whenever you observe these letters E minus or this letter mu E, this is E plus and mu bar suffix E. The lepton number of this electron is +1. This is anti-lepton. This is L minus. L minus 1 category. Next. So this lepton muon. So these are also in the two categories are there. One is mu minus and there and or else like this. Okay. mu plus, or else the design like this: mu bar mu. This is lepton number plus. This is the lepton minus. Okay. In the conservation reactions, if you yes, if you try to observe these things, this is mu bar. I mean mu. So frequency type written for mu. Okay. For this letter is anti-lepton. This is lepton, normal lepton. Next, tau ends. Lepton, tau. These are two categories are there. Again, these are the normal tau elements, and they are also like this. And these anti-tau elements like this, tau plus and mu bar tau. L tau equal to, that's one category, and L tau equal to minus one category. So if you remember, negative charge, okay, not uh, not negative charge, and no bar. Remember this word, lepton, leptons. This number is plus one, lepton number. Positive charge with bar, anti-leptons, light weighted particles. So remember, please try to remember words, then you can easily find the conservation of lepton number within second. Okay. So in case if you observe these categories, 1, 2, 3, 4, 5, 6 categories. Out of these 6 categories, all the lepton numbers are zero. Okay. Here they remember minus charge, no bar. These elements here I've designed these ones, right? Are the general leptons. So positive charge with bar. These are anti-leptons. Okay. Now we are going to test our classification. The first reaction is uh, so okay. First reaction here I'm going to mu bar. These are all gate and net questions. E minus plus mu bar E plus bar mu. Okay. Now we can check this is conserved or not. We need to check this one, the conservation of lepton number. Here also I'm going to give one more note. So this note I observed, this is the textbook. Digital textbook elementary particle classification is very very good, so we can understand easily. So what I observed here, first we need to check in the conservation of lepton number. So everybody is going to uh, just put their values here after seeing the classification. That is not the right way to do the, I mean, check the conservation of lepton number. So in case if you follow these blind rules, and then you can get note here how to check lepton number. One important LE. This is the order L mu, L tau must be separately conserved in any reaction. This is the key now. Okay, this is the key. No, remember this one always. First, we need to check LE. Okay, I'm going to check LE. What is LE? LE. Here already the LE is there, right? LE. So conservation of lepton number in terms of electron. So this electron 0, right? Tends to this one electron. This is the plus 1 discharge S, and this one mu bar. See here with bar and the lepton, right? This is minus 1 plus this is not under the category of, so remaining all this one is here. Therefore 0 tends to 0. Then everybody saying this is conserved, but it is not conserved. Let us see. I want to check this one. This is how we need to find the solutions. Okay. So in case if you clear CSR net and GRF, you get CSR fellowship. So 3 years, 5 years, depends upon the your work. Uh, Here I'm going to check this lepton number in terms of mu particles. This is mu. This is not bar, just minus, right? So this is or something plus 1 charge tends to, this is electron 0 plus 0. This is mu bar, right? This is already plus and this charge is minus 1. Therefore, this is not conserved. So this is very, very, very important issue. It is not conserved. Under what category? This is lepton category. You need to check this order. Please remember this order, then you can get correct answer. So don't go for any blind things, shortcuts. Okay? You need to read textbooks and you can make some notes. Okay, then you can follow the question and answers. You try to solve question and answers by using textbooks, then you can get a day by day better. Then you can get some confidence. Then you can crack the national exam. The only solution you want to crack national exam. There is no other choice. You need to understand the subject very well. So for that, you need to study the textbooks first, basic textbook, whatever you like. So that is your. I don't want to recommend any textbooks. So here I'm following some textbooks are there. Okay, next example. Next example two. That is for enough for explanation conservation of lepton. Then we can check first. This is mu plus tends to e plus plus mu e plus mu bar mu. Okay. Uh, so we need to check this one whether this one is conserved or not. Okay. Okay, first I'm going to checking e plus. So this is not e plus, right? Then I'm going to give this one is 0. I know already. So this is e plus. This is minus. Okay. Plus. Here there is no bar. Then I can recognize this one is plus. This is not a under category of electron, lepton number. This is 0. The entire equation is conserved. Okay. Next category is L mu, right? Then you can check this one. This is anti lepton number. This is 0. This is not category of anti-lepton mu category. Plus this is 0. Okay. This is bar is there already, which means this one minus this conserved. Therefore, no need to check another this tau. So in case if you check tau, what you will get? Check tau also 0, 0, 0. Just 0. It is conserved, right? So therefore, this reaction is conserved. So this is how we are going to check conservation of lepton number. For that, you need to remember this table. This table is very important. You need to design the a classification like this. You can make these notes, then you can follow these three rules. So one is the negative charge, no bar, that is normal lepton. Uh, lepton number is plus one that category. The material, the elementary particles denote the positive charge with bar. Those are under category of anti-lepton categories. Next, thumb line bodies are not this one. You need to check this order level. Most of the case, in case if you check the E category and mu category, it is conserved. And automated tau also conserved of the case. Or else you need to check all the three and only conserved. So for your practice, I'm going to give one another example. Example 3. So you need to check this one. K plus tends to mu plus mu. Okay, is conserved or not?